Section 4.2, Place Value or Position Value Numeration Systems. The value of the symbol depends on its position in the representation of the number in a place value numeration system. It's the most common type of numeration system in the world today. It's the system that we use in the United States, which is called the Hindu-Arabic Numeration System. A true positional value system requires a base and a set of symbols, including a symbol for 0 and one for each counting number less than the base. The most common place value system is the base 10 system, and it's called the decimal number system. In the Hindu-Arabic system, the digits that we use are 0 through 9. The positions in the Hindu-Arabic system, the positional values starting from the right, 1, and the next position moving to the left is 10, and then 10 squared, 10 cubed, 10 to the 4th, and so forth. To evaluate a numeral in this system, multiply the first digit on the right by 1, the next digit by 10, the next one by 10 squared or 100, and so forth. In general, we multiply the digit n places from the right by 10 to the n minus 1 to show a number in expanded form. Write 1, 2, 3, 4 in expanded form. So working from the right, we have 4 times 1, move over to the 3, we're going to multiply 3 times 10, and we move over one more to the left, 2 times 10 squared, 1 times 10 cubed. Or we can also write it like this and show the actual power of 10 multiplied out. The Babylonian numeration system is the oldest known system that resembled a place value system. It was developed about 2500 BC. It represented a place value system with a base of 60. It's called a sexagesimal system. But it's not a true place value system because it doesn't have a symbol for 0. And that led to some confusion and ambiguity in the representation of numbers in this system. So they only have 2 numerals. They're shown here. And the positional values with a base of 60, 1, 60, 60 squared, 60 cubed, or equivalently if we multiply the amount shown there. A gap is left between the characters to distinguish the place values. From right to left, the sum of the first group of numerals is multiplied by 1, the next group by 60, the next group by 60 squared, and so forth. And we also have a symbol in this system for subtraction, and that's the symbol we use there. It says to subtract whatever is to the right from the symbol to the left. So let's write this number here as a Hindu-Arabic numeral. So let's lay out what we see. So we've got 2 positions. So we know we're going to have units and we're going to have 60s. And then we look at the value of the numerals that are shown or symbols that are shown for each position. So here we have 10, 20, 30 plus 4, 34. And over here we have 10, 20 plus 1, 21. Now this is worth 60, so we're going to multiply 34 by 60. This is worth 1, so 21 times 1. Multiply it and then add those together. So this represents 2061 in our system. Now we want to go the other way. We want to take 7223 to a Babylonian numeral. So you're going to divide this number by the largest positional value less than or equal to that number. So remember the positional values in the Babylonian system, and the largest one less than or equal to 7223 is 3600. So we're going to divide 7223 by 3600. We get 2 remainder 23. So there's going to be 2 groups of 3600. Now the next positional value is worth 60 if you notice, but 23 is less than 60, so we aren't going to have any numeral in that position. There's going to be a blank there. We don't have a symbol for 0, so we're going to have to leave a blank. And then the 23 are going to go into the units position. So here's what we have. And again, remember there's no symbol for 0, so we're just going to leave a big blank here and hope the person reading the numeral understands that this position has no value to it. And that's where the confusion came in that system. Now let's go the other way. Let's write this as a Hindu-Arabic numeral. 2 positions. This is worth 60, and this is the units. And notice we have a subtraction here. So this is 1, so that's going to be 1 times 60. This is 10 minus 2, or 8. So 1 times 60 plus 8 times 1 gives us 68. The Mayan system, in this system, like the Chinese system, we're going to write things vertically. Units position on the bottom. The numeral in the bottom row is multiplied by 1. The next row by 20. The next row by 18 times 20, or 360. And the next row by 18 times 20 squared, and so forth. So the positional values in this system are 120, 18 times 20, and so forth, or multiplied out. Here's the values of those positions. And then here's the symbols, and these are really easy symbols to remember because there's a nice pattern. And we do have a symbol here for 0, which makes it a much more concise way and clear way to write the numbers in this system. So let's do this one as a Hindu-Arabic. So we start at the bottom. These are the 1s, so 4 times 1. Next position is worth 20, but that's a symbol for 0. And the next position is worth, remember it was worth 360, and then the next position is 18 times 20 squared, and we see a 2 here. So here's what the values are. We add them all up, and we get 17,284. Now we want to write this as a 4025 as a Mayan numeral. Just like we did with the last system, with the Babylonians, we're going to divide 4025 by the largest positional value less than or equal to it, which is going to be 360. So we divide by 360, we get 11 with a remainder of 65. So then we're going to take 65 and we're going to divide it by 20, the next positional value. We get 3 with a remainder of 5. So if you notice here, the important things we have are 11, 3, and then there's 5 units left over. There's what it looks like. And you're going to do it, remember, vertically. So you look at the numerals from the table. Here's a numeral for 11, for 3, and for 5. And there's the representation of 4025 in the Mayan system. Write the Mayan numeral as a Hindu-Arabic and then as a Babylonian. So we're going to do 2 exchanges here. So 2 numerals, 2 groups there. The top one is a 13 and the below it is a 14. Top positional value is 20. The one below is 1. So we have 13 times 20 plus 14 times 1. We get 274. Now we know that this is 274. We want to write this now as a Babylonian. So we want to divide 274 by the largest positional value less than or equal to 274. There's the positional values. We're going to divide by 60. We get 4 remainder 34. So 4 groups of 60 with 34 units remaining. And let's take a look here. Remember our symbols. We only have 2 symbols, right? So 2 groupings we need. And we need 4 groups of 60. So I see B or D, but then I also have the 34 units left over in the 1's position, so the answer has to be B.